Welcome to the webinar on calculating energy storage systems. In the next few minutes, I will show you how our calculator works, what some typical use cases are, and what the results are. As you know, energy storage systems or batteries have become increasingly popular recently. It is important to size the battery correctly because only then can we achieve maximum savings, maximum profit, or the shortest possible return on investment. The battery calculator is available at this address. You need to have a Google account to access the calculator. If you do not have an account or a license, a page will appear that looks somewhat like this. If this appears, please contact our sales team, who will provide you with a test account. At the beginning, there are some brief instructions. Here you also have the documentation, which is quite detailed and covers a wide range of scenarios. So I encourage everyone to read this documentation before use. The documentation provides some typical use cases and how to resolve issues. Let's return to the calculator. At the beginning, we determine the data for the price and the network fee. The data is based on the day-ahead price, meaning given in advance. Initially, the country is selected according to which we determine the prices. I will take Slovenia as an example. Then the import and export fees are determined, meaning the duties for importing and exporting energy. Export, if someone has a solar power plant, how much duty one has to pay for exporting. All these duties are given per kilowatt hour. Here we have some default values, which we have obtained as a combination of costs, network fees. If we know that the cost of network fees in Slovenia is approximately 20 euros per megawatt hour. To this, we added a package from the electricity supplier, which charges just under 12 euros per megawatt hour. Altogether, these are all the contributions for importing electricity, meaning the supplier's contribution plus the network fee contribution. This is only the supplier's contribution, as the network fee is free throughout Slovenia for exporting electricity. Here you can add any other costs you essentially have with your supplier. It is necessary to state what the limits are, meaning what the fuses are, what the meter reading is for importing or exporting electricity. We will take one example, 600 kilowatts a larger user. Usually 80% of this is export limitation. You can set this freely. To start, I would like to show you a very simple example. We only have a battery which is exclusively intended for arbitrage, meaning for buying and selling electricity. And we have some of our own. In the demo, we have solar power plants. So we will skip this, and we will also skip solar. Here we select a period. By default, the period of the last year is selected. And what we will optimize, as I said, I'm setting an example. We set the battery. And for the test, we can take, for example, 500 kilowatts or a 250 kilowatt hour battery with a C factor of 0.5, which means 250 kilowatt hours, 125 kilowatts, the battery is capable of delivering power. the efficiency of one cycle, which means we have 92% efficiency here. Approximately 8% is the average loss in these cases for batteries of this size. And we also specified the minimum and maximum state of charge, meaning the battery's charge level. Then we click on Optimize, and this calculation takes into account, as I did before, the prices given for the entire period of the last year. Such a day finds the optimal way for the battery to operate, so it charges when energy is cheapest and discharges when energy is most expensive. And with this, in 1 year, we can earn a good 8,000 euros with this battery through so-called arbitrage, meaning buying and selling. We can also print a more detailed and nicer report, which is more suitable for printing. Here we can add the project's name, purpose, date, and so on, whatever we want. Whatever suits us, we can add something else, the address on the report. If there are more of those, we can also expand a little. This report provides key data from when to when it was done at indicative prices, whether we had data on electricity measurement, whether we had data on solar production, and so on. At the bottom, a more detailed way of how this optimizer works is also shown. This line on the graph, as you can see, these are electricity prices. When prices are at their lowest, energy goes from the grid into the battery, as you can see with this display. When prices are at their highest, energy goes from the battery back to the grid, and in this way, we profit. This black line is the cumulative profit. As you can see, it first drops because the battery is charging. Then, when the battery discharges, it grows and grows and grows. And so at the end of the period, we have some profit. On this graph, it is shown from the last 7 days, it also says here, but it actually happens throughout the year. Such a profit is, of course, only possible by optimally managing the battery, for which we have our Reduxi EMS. This report can also be printed. You can save it as a PDF and share it with others. This was a simple example. We can also take a slightly more complex example. I will restart this calculator with the same power. Now I will actually select some data from the electricity meter. If you don't have such a sample, you can select a sample file here. It looks somewhat like these. The key data from the meter are, in the first column there should be a timestamp, for example, the 1st of January 2025 at midnight, followed by 15 minutes later. We want to have every 15 minutes. Ideally, but also every hour is okay. We want to have data from the meter. This can be energy or power. In this case, we have power. We prepare this file so that it is ready to be uploaded. Below we see what we have actually read. We have read the start of the interval, the end of the interval, from night to 15 time fullness. Such and such power was in this interval. Here, the data has been pre-filled for us, indicating which column from this file is marked as a timestamp, which one is power energy, and what are the units. Do we also have a solar power plant at this location? Yes, let's say we do. Similar to before, we upload the data of the solar and sun power plant. Here we can see what we upload from a reference file. Just like before, this file will contain some timestamp and some generated energy in this case. As you can see, there's no production at night. It starts in the morning when the day begins. During the day, it's highest, around 60 megawatts, and then in the evening, again, none. Let's load this solar production. Let's check that all the data is correct. It is. Similar to before, we will analyze within a specified time period, which can be at most the period for which we have data. Our sample data is only for 2 months, so we will also conduct the analysis for 2 months. We take one battery, say 500 kilowatt hours. We'll leave it as it is and click Optimize. The report is now a bit more advanced. We have the data for this period that we selected. We have the information on what the daily earnings and annual earnings are. So let's focus on the annual earnings. Based on the data from our meter, we determined that we would pay approximately 21,500 euros per year for electricity. If we only had a battery, meaning no self-consumption, no solar, but solely a battery connected to the grid for the purpose of arbitrage, with such a battery, we would earn 8,200 euros. Approximately the same as in the previous example if we had the same battery. If we only had solar, meaning no self-consumption, no battery, but only a solar power plant, in these 2 months, or in this period converted to the whole year, we would earn 35,000 euros. So in total, the earnings would be around 43,000 euros if we consider having both a battery and solar. But because a lot of this production from the sun and energy from the battery is consumed for self-consumption, to cover these costs, we have additional savings. Because we don't need to pay for the network, we don't need to pay the supplier's cost. We have additional savings amounting to 7,000 euros. So 8 plus 35 plus 7 and a bit more brings us approximately 50,000 euros in savings throughout the entire year. So instead of paying around 21,000 euros, we have these savings of 50,000 euros or profit, and at the end of the year, we can earn 29,000 euros from this. Similar to before, we can look at the record, which now includes these similar data, a bit more data on how the solar works, how the battery works when certain energy is transferred where. If we want to change any parameter, let's say I'm interested, this battery might be a bit too large. What about if we took a 250 kilowatt hour battery, we click Optimize the same way, we get the result. In the previous example, it was approximately 50,000 euros annually in savings or advantages benefits. For a smaller battery, not even that much worse, the benefits are 44,000 euros. So, maybe it's more worthwhile to take a smaller battery because it needs to be sized appropriately according to solar data and consumption. Now I would demonstrate maybe another example. If we don't have all the required data, let's say we start again with the same grid fee, we don't have data from the meter. But since we know it's important, we can say, aha, we know what the monthly consumption is. Okay, let's say we have a monthly consumption of about 70 megawatt hours. And we mostly have a daily profile, meaning the consumption is from 6 in the morning to 6 in the evening. So during this time, it will be about 90% of the total consumption. We don't even have solar measurements, but we do have solar power, where the installed capacity is approximately 200 kilowatts. So without specific data, but only with approximate ones and in the same way as before. We choose a battery again. If it's somewhat smaller, this optimization will take a bit longer because we have the whole year in the analysis, not just 2 months as before. In the meantime, while we wait, I would show another way. From my electricity, which is also mentioned on this calculator, how the data from my electricity is obtained. Our calculator allows for the direct import of this data. Getting something from my electricity provider is like this. So the metering point, GSR, and so on, and also getting what kind of energy was produced and consumed in a certain interval. This file is knowledgeable for import into our calculator, which I will also show you what is. Shown. So with the help of some approximate consumption estimates, monthly consumption and solar production, and with a battery that we have chosen, we see what the savings are, what the total benefits of a battery and a solar system are. For example, what if we don't have solar? If we don't have solar, we can skip here. That's one option. Another option is to exclude the solar here. So we don't wait too long. We will choose a slightly shorter time period. For example, 1st of May and up till today.
Let's calculate.
So one such battery would bring us 6,500 euros in savings in 1 year combined with solar. The calculation would be different, allowing us to test various scenarios for the battery without the battery, just consumption, just solar. If we look at just solar and just consumption, what would that return to us? Just solar brings us 8,400 euros, and due to self-consumption an additional 5,000, so a total of 14,000 is brought by just solar. The battery adds even more, and with these different options we can calculate what is the most optimal calculation for a specific location. That was all from my side. Here they require additional documentation, as you can verify everything once more.